Right, let me make it smaller, it's just a bit difficult with the phone, so I have actually ordered some stuff, like a head thing and a chest thing. Just wait for it to refresh, because it's quite a large amount of data. Oh, there you go, look at that. It speaks for itself, doesn't it? So the circuit was basically working overnight, no external power. Yeah, power's turned off. And now we have cell balance. Okay. What'll be interesting is to actually turn it on and see what the voltage is of the whole pack, because that will be an indication of the efficiency. If the whole pack's voltage hasn't dropped, right, then it's reasonably efficient. I would say it's obviously arbitrary, but you can obviously see, right, so this is obviously the point where I turned on the charger, right, and then this is at the point where I actually connected the cell balancer and then just left it to do its thing, right? And you can obviously see this one is roughly between those two, which means it has done the job, right? And it's robbed the most power from the depleted cell, which I understand, because it's not the voltage, you see. This one was actually partially depleted already, right? This one was actually quite full, and so it's robbed some charge from it, but the voltage hasn't dropped that much because it has a lot more in it than the other one. And so this one is obviously far more depleted now, because let's just say this one maybe was 40%, this one was maybe 70%, and this one was, say, 20%, just as an idea, right? So obviously it's then risen its charge now to 40%. This one, which was at 40%, is now at, say, 30%. I don't know. I'm just spitballing here. And then this one, which is at 70%, is now at, say, 60%. You see? But it's really interesting, isn't it? It's very interesting, that. Yeah, it's still going. And I believe it's kind of plateaued, but it doesn't look like it has yet, because it's still doing it. Yeah. Although it's obviously, the initial charge was fast and then it slowed down. Now, that's interesting in its own right, actually. Yeah. This is I had to get the thing for the pin out, so obviously there you go. You got the sheet. It is one of those. Yeah. Okay. And the buck converter that I'm using, it's an off-the-shelf buck converter, which is, reasonably efficient. 300k, I think it runs at, for the sample, the PWM output sample. Yeah, so very, very good. Works. Right, let's do it then. Let's turn on the power to the power pack. Right, and then we've got 0 current, so it will actually show the voltage. Okay. And it hasn't. Let's move this wire out of the way. It still seems to be 11.5 actually. The combined voltage. In fact, if we add the cells, it should give us the pack voltage. It shouldn't it? Yeah. Equals. So. Hope you can see what I'm typing. It's these three. Yeah. 11.2. Yeah. Right. And then, okay, this is where it gets a bit funny. If I can do Control Shift and then Control D, and then we wait. Because it's a lot of cells. Excel would have blown up. Its limit is 64k cells, isn't it? Excel, and this is 220,000 cells. G-numeric is obviously far superior. Maybe not as pretty, maybe there's some functions that are missing, but in terms of pure data crunching, forget Excel. This is the way. Yeah. And this is actually relatively low. I have actually done it with like 1 million cells, rows, 1 million rows, and a bank of cells, and it's slow, but it does work. It doesn't crash out Excel, forget it. It's a joke. And to be fair, LibreOffice doesn't really hold a candle to this either. You know, whoever built GNumeric knew what they were doing. Yeah, I've never had it crash. Oh, there we go. Right. So I can add it in. No. Oh, I'll just do a line. Let's see. There you go. Right. So obviously there's the charge. I mean, this is not the actual graph. It's just doing the example. So it discharged there because the total charge of the battery, it was just basically sat. Yeah. I guess this would be where I connected in the third cell, and so it's kind of self-discharged, I guess. You know, maybe that's just because of the metering. I don't know. I'm not sure about that. That's interesting. It's not flat, but there you go. And then I connected the charger, and now it's doing the cell balance, and obviously the voltage has actually dropped. So we've lost some. Now the bottom here is 11.1, and the top is 11.7. Right, so it started off as 11.5, which there you go, yeah, and then it's dropped now to a lower voltage, 11.4. Okay, yeah, interesting, very interesting. You know, all of these experiments anybody can do themselves. The lithium cells, obviously, you'd have to buy, and they're not cheap. These ones are about £40, $50 each, I think, something like that. So there's $150 of cells there that I'm experimenting with. But you don't need big cells like this. You can actually do it with reasonably small cells. You can do it with these ones. Except for I can't see them anymore now. Yeah, there's the 32650. Is it no? 16650s. The common pencil cells that you get, lithium ones. You can do it with those. You know, and the experiment will work the same. And those are very cheap. You can get them for about $1 each now, can't you? Something. Yeah. So you can do it with small ones as well. The experiment should work just as well. And the voltages and stuff should be just as well. But that's interesting. I should add that in, shouldn't I, really, into the plot. Cool. Right. Yeah. Oh, I've got a meeting now, so I'll have to get off. Don't forget to like and subscribe. Why am I saying that? Professional videos say you need to like and subscribe. Yeah. I think like promotes it in the algorithm, so more people see it. And subscribing means that if I do updates, you get a notification. So it just makes life easier, I guess. Do I get anything from it? Immediately, no. But ultimately, if I get thousands of subscribers and loads of likes and stuff like that, then yes, YouTube pays me something. But that's not my primary income, so I don't care too much, really. It's more for you. Okay. Oops. I zoomed in there for some reason. All right. Thanks.